Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the addition rule for probability. So before we get to that, let's look at this example. So let's say that headmaster gets over the PA and he says, I want to see everyone in the school who plays soccer or cricket. So let's say 250 students at the school play soccer. And let's say 130 play cricket. And there are 60 students who play both. So how many students would end up coming, assuming they all came? Okay, we've got 250 who play soccer, and we've got 130 who play cricket. But the problem is, these 60 who play both, they would have been counted here as part of the 250 that play soccer, and also here as part of the 130 that play cricket. Because it didn't say it was 250 who play soccer only, it's 250 who play soccer all up. So I've counted those 60 students who play both sports twice, but I only want to count them once. So the total number of students that will come, I do add 250 and 130, but I need to subtract the 60 who play both because I've double counted them. So actually 320 people would come. So this is the same as if we were looking at the probability of something or something else happening. So the addition rule for probability is similar. So if I want to know the probability of A union B, remember we can read that union symbol U as OR. So the probability A or B happens, remember that means either A happens, B happens, or both happen. So what you do is you add up their respective probabilities. So just like we did in the example, we added up the number of people who played soccer and the number who played cricket, but we need to subtract the number who play both because we have double counted them. So let's look at this in a Venn diagram. So we'll draw up two sets. So like A could be, say, the set of all students who play soccer and B who play cricket. So if I want to find the probability that someone plays soccer or cricket, so the probability they play soccer is the proportion of people that end up in this circle. The probability that they're in set B is the proportion of people that are in this circle B. As you can see, I've shaded the middle twice. That's why it's been double counted and why I need to subtract it. So this is the rule for probability. So the probability either A happens, B happens, or both happen, you add up their respective probabilities and subtract the probability that both happen. Let's look at a few examples. So let's do this one here. I pick a card from a deck. What is the probability that the card is a king or a spade? Of course, that means what's the probability the card is either a king, a spade, or both? We have to include the case where it's both. So probability, I'm just going to call it K for king, or S for spade, is the probability I pick a king plus the probability I pick a spade minus the probability that I get a king and a spade. So the probability I pick a king from a deck, so there are 52 cards in total and we have 4 kings. So the probability would be 4 over 52, which is 1 in 13. The probability I get a spade is 1 over 4. But because there are 13 kings, I included in that the king of spades. When I was counting the spades, the 13 of them, I included the king of spades. I've included the king of spades in this calculation and this calculation. So I need to subtract the probability of both. The probability I get the king of spades, the probability I pick a card that's both a king and a spade is 1 over 52. So I need to subtract it. So you can use your calculator if you want to do this. You should end up with 16 over 52 or 4 over 13. Okay? So again, we just added the probability it was a king and the probability it was a spade, subtract the probability of both. Let's look at another example. So let's look at this question here. Roll a die, toss a coin. What's the probability I either get heads or an even number? Or both? Obviously heads refers to the coin, even number refers to the die. So the probability, I'm going to call it H for heads, or I get an even number is the probability of heads plus the probability of an even number minus the probability of both. So, probability I get a heads on the coin is just a half. The probability I get an even number is just a half. So if I just added a half and a half, I'd get 1. Well, clearly the probability I get a heads or an even number is not 1. It's not certain because I could get tails on the coin and I could get an odd number on the die. So I need to subtract something, and that is the probability that I get heads and an even number. So if I toss a coin and roll a die, the probability that I get heads and an even number is just a half times a half, which ends up being a quarter. So there's a 1/4 chance that the number I get is even and I get heads on the coin. So half plus a half minus a quarter is 3/4. So there is a 3/4 probability that I get heads or an even number. So it turns out that sometimes the probability that both events happen is 0. We're going to look at that now. So 2 events are said to be mutually exclusive if they cannot both happen. So what they do is they exclude each other from happening. So examples of mutually exclusive events. So let's say you toss a coin. The 2 events that you get a heads and a tails are mutually exclusive. You can't get a head and a tails if you toss a coin. You can only get one of them. Of course, you could roll a die. The events say 2 and 3. They are mutually exclusive. You can't get a 2 and a 3. They stop each other from happening. Let's say the weather tomorrow. It rains or it doesn't rain. They are mutually exclusive. It can't rain tomorrow and also not rain. Other examples, you get an A in maths, you get a B in maths. They are mutually exclusive. They can't both happen. You can only get an A or a B, but you can't get both. So obviously, if they are mutually exclusive, then we have that the probability of A and B both happening is equal to 0. So that's true if A and B are mutually exclusive, meaning that they stop each other from happening. So when that happens, it just makes the calculation above a little easier because the probability of both happening is 0. Let's look at an example. So one that you probably already know. So let's say I roll a die. So what is the probability that I get either a 3 or a 6? So the probability you get a 3 is a 1/6. The probability that you get a 6 is also 1 out of 6, 1 over 6. But they can't both happen. The probability they both happen is 0. So I don't even need to write the 0. So we know the probability will just be 2 over 6. You probably could figure that out even if you didn't know the addition rule. So let's look at an example where it might be a little more useful. Let's say now I pick a card. So what is the probability the card I pick is either red or a spade? Well, this shows you 2 mutually exclusive events. I can't pick a card that's red and a spade because if it's a spade, it'll be black. So the probability that it's red is a half. Half the cards are red, half are black. Probability it's a spade is a quarter. I don't need to subtract the probability of both happening because they are mutually exclusive. So probability I get a red card or a spade will just be a half plus a quarter, which is 3/4. So this is the addition rule for probability. This is how you find the probability that 2 events happen. Either the first event happens, the second event happens, or both happen. You add up their probabilities and subtract the probability that they both happen. If the events are mutually exclusive, meaning they cannot both happen at the same time, then this here probability of A and B will be 0, and you just add the 2 probabilities together to find the probability that A or B happens. All right, this has been the luckiest maths teacher in the world. Have a great day.